everyone. Welcome to the Design Lab 2. You are here with Ashwin, Dharini, Ravi, Saurabh and Shafali. In this video, we are gonna show you the assembling process of the job-made measuring tape. Measuring tape is one of the popular tools found with every handyman. This spring-driven retractable tape measure removes the guesswork from the operation, giving it error-free work environment. Now starting with the product overview, the job-made measuring tape comes in many variants and is used for measuring linear distances. The one we have chosen is dull red tape, which has 7 parts, which are plastic body, tape, lock, rubber washer, top cover, handle and screws.
Overview. With reference to Design Lab 1, we are going to carry out 3 trials. In trial 1, a trained operator performed the assembly operations and duration of each task was recorded. Even though the worker is performing at his best, or at least trying to do his best, the assembly line isn't efficient. This made us realize that there is no point in making the operator work harder when the system he is working in is designed to slow him down. Hence, we are targeting on improving the work system. We encountered a handful of setbacks which were slowing down the process. If we look at the workstation setting, components and tools are not in a fixed place and are not easily accessible. For example, look at the screwdriver in workstation 2. Tool which the worker uses with his right hand is placed close to his left hand, and also the top cover and base plate are scattered across the workbench. Apart from workstation organization, the other significant problems were problem with retraction of the tape, lock placement, handling of the screws and handle. When a normal distribution curve is drawn for the time taken to assemble one product, it is clear that 42% of the time we cannot meet the targeted production with this setup. That means nearly half of the time our customers are unhappy. As an industrial engineer, we love happy customers, isn't it? Analyzing our problems and results, we need a production technique that improves the production, reduces the variability, and of course, reduces the number of defective products. Lean Six Sigma covers all our requirements. So, let us implement one technique at a time and see how it works. Lean production system focuses on maximizing the share of value-added activities, implementing stable and standardized work practices, and it takes a holistic supply chain perspective, that is, it's customer requirement driven. Lean terminology. 3 M's of Lean: Mura, Muri, and Muda. Mura in our process is fixing the spring coil of the tape in the notch and handling the tape carefully. These are the inconsistent operations leading to Muri. Muri is if the tape unwinds, the worker spends his productive time on trying to wind it back, a non-productive activity. Worker handling the tape will have to work hard, and the worker in the next workstation has to be idle until a good product reaches him. Mura and Muri are the progenitors of Muda. Here, waste of productive time.
To overcome these problems, we choose to implement 5S methodology in our existing system. 5S is nothing but a Japanese system for organizing spaces so work can be performed efficiently, effectively, and safely. The first S in the 5S stands for sorting. During sorting, we discarded the items that were not in use, making the workstation clean. We tried to sort the items on the workstations in order of their usage. We can see that the workstations are clean after the implementation of sorting. The second S stands for set and order. By following Seitan, we gave fixed spaces to all the equipments and tools. In this trial, we can see that the operators keep the equipments back at their respective spaces after every usage. The third S stands for shine. In this, we clean the working areas by identifying the root cause of the dirtiness. We tried to clean the tools and kept it in the ready-to-use condition. Ensured that there are proper lightings and air ventilation. The fourth one is standardizing. We standardize the whole process and try to follow the same set of working procedures, resulting in less variations. The fifth one is sustain. There should be discipline that needs to be followed by operators, and they should be aware of all the procedures involved in the assembly line. Regular audits and reviews are to be done. Now, on comparing the outcomes of the trial 1 and trial 2, we can clearly see that we were able to cut down the cycle time from 24 seconds to 22. We were also able to reduce the idle time from 22.7 seconds to 10.7. We managed to increase the efficiency of the system by 10% and were also able to make the system cost effective. Out of the existing 9 problems, we were successfully able to achieve line balancing, stop tape retraction, and reduce the distance between the workstations, but could not achieve several issues related to lock, screws, and so on.
This graph represents the variability in trial 2, where the red shaded region shows that 24.51% of the time a product takes more than the cycle time to get assembled. Even after implementing Lean, we are unable to mitigate all the problems. Therefore, in order to address the remaining issues, we are using Six Sigma. First of all, what is Six Sigma? Six Sigma system is a comprehensive and flexible system for achieving, sustaining and maximum business successes. Six Sigma process strives to achieve this by careful understanding of customer needs, use of facts through data collection and statistical analysis, and by managing, improving and re-engineering production as well as business processes to increase customer satisfaction and business excellence. And here by business excellence, we are talking about cost reduction, productivity improvement, growth of market share, customer retention cycle, time reduction, defects reduction and change to quality culture. To achieve a near perfect Six Sigma quality, the defect rate in the production of each component should not be more than 3.4 parts per million defect opportunities. Six Sigma system recommends a 5-step problem solving methodology for organization that wants to become a Six Sigma organization. DMAIC is a data-driven quality strategy used to improve processes. It is an integral part of Six Sigma initiative. Define. It is first phase of Six Sigma. Here we define the problem, improvement activity, opportunity for improvement, the project goals and customer requirements. Measure. In this phase we measure the process performance. Analyze. We identify the root causes of variations and poor performance. Improve. It improves the process performance by addressing and eliminating the root causes. Control. It controls the improved process and future process performance. Now let's move on to implementing Lean Six Sigma in our assembly process. First, we need to define the problem that we are still encountering even after implementing Lean. It is possible to define a problem only if it is definable, measurable, specific to standards, attainable, reasonable and with some time bound. Smooth surface of the tapes, we encounter unexpected unbinding of the tapes on numerous occasions. Problem 3. Since a lock can be placed in a base part in two different orientations, workers often get confused. Problem 4. Holding the handle on the top cover and screwing it simultaneously is a difficult task. Now that we have defined the problem, let's go to measure. Measure. We measure the improvement in our assembly process on the basis of the time taken to assemble each part in the assembly line. However, we need to measure the performance of the existing process, that is trial 2. This is done using normal distribution curve. Let x be the random variable, in our case time taken by the system to produce one part. Let mu be the mean time of trial 2 and sigma the standard deviation obtained. Now we need to calculate the probability that the random variable is less than or equal to the takt time. On subtracting and dividing the left hand side and the right hand side of the inequality by mean and standard deviation, As shown, the LHS value corresponds to the z values of normal distribution. On further simplification, we get z is less than or equal to 0.6934. From normal distribution, this value corresponds to 0.7549, which is equivalent to 75.49%. This value signifies that in our assembly line, only 75.49% of the time a product is produced within cycle time.
Under analysis and improvement phase, we studied different attributes of all 7 components which comprises the final tape assembly, and then we correlated it with the problems which were still persistent after trial 2 attempt. Here we have jotted down few resolutions which we found most feasible to implement in real practice. In trial 2, we observed majority of assembly time was being consumed on tightening the screws. So we found the scope of improvement to reduce the overall assembly time marginally with the help of electric screwdriver.
The problem with lock placement is dealt by placing a white colored dot on the body and on the lock.
After analysis and improvement phase of DMAIC cycle, here it comes the control phase, wherein we implemented few practices which will control the improved assembly process and will produce the products within acceptable defect variations. We suggested providing the name tags for the storage bins. Then we're providing the operator's manual. Then recommended practice we provided the name tags for each storage bin. We kept operator's manual at every workstation to perform the designated task as per established standard. We recommend the use of periodic audit forms in order to maintain the performance of process and the quality of products being assembled.
Now, let us see the demonstration of trial 3. In this video, we are trying to demonstrate our Lean Six Sigma recommendations. Elastic band is used to demonstrate how unwanted unwinding of the tape can be avoided. A small wire is attached to the spring to demonstrate the tag. Using these two redesigned recommendations, the worker at workstation 1 can complete his task with minimum variation. Since the handle and rubber washer are now the integral parts, the number of operations is reduced.
This graph represents the variability in trial 3 after implementing Six Sigma. This graph is drawn about a mean of 21.046 with a standard deviation of 1.17. It can be seen that in this graph the red shaded region shows that only 0.6% of a time a product takes more than the cycle time to get assembled. This graph compares the variability in trial 2 and trial 3. Blue line indicates the trial 2 while red dotted line indicates trial 3 with mean and standard deviation stated on the top corner of the graph. It can be seen that trial 2 is more like a bell-shaped graph with a large standard deviation. On the other hand, trial 3 is more narrower looking with comparatively less deviation from the mean value. Hence, variability is reduced through Six Sigma processes.
After trial 3, here we again introduce the summary table to describe the improvement in assembly process with 3 different trials. After implementing Lean Six Sigma, we could able to reduce the number of workstations from 4 numbers in trial 1 to 2 in trial 3. At the same time, as we have assigned one worker per station, we could be able to reduce the number of workers equivalent to the number of workstations. We can also see the improvement in overall performance of an assembly line with the help of Lean Six Sigma methodology. We could able to reduce the overall cycle time from 23.2 seconds to just over 21 seconds. On the other hand, we could able to reduce the idle time substantially from almost 22 seconds to just over 7 seconds. As the number of workers got reduced to half from trial 1 to trial 3, we could actually able to reduce the weekly expenses on workers' wages by 85%. Also, we could able to mitigate all the problems we encountered in trial 1 after implementing the Lean Six Sigma. The application of handle, which was supposed to be fixed at the back end of the tape. and we realized it as an additional secondary attachment which can be an integral part of the back cover made of plastic. Similar to the handle, this triangular rubber washer being small secondary component which were having chances of misplacing while assembling, we integrated it with the main body. We noticed that the task of inserting the tape reel into the main body was taking unpredictable time. So we used a non-removable tag just to hold the spring of tape reel and insert it into the notch of the main body part.
Thank you.